Hey guys, welcome back to Maths Recovery with Rebecca. So today we are going to be diving deeper into reduction angles, and we're going to be looking at them over many operations. Now remember, your operations are times, divide, plus and minus. So plus and minus might include some sort of common denominator or factorizing. So if you get stuck on any of these, you are more than welcome to go and look at my factorizing videos, so just to try brush up. But the level in this video should be fine. If it is not, you need to go back and look at the factorizing videos. Okay, so let's look at the first one. So on the right hand side there, I have got my little table that we looked at previously in the first video. And what we're looking at now, the question over there, reducing. In the last video, we looked at a specific value in a quadrant. Now what we're going to do is we are just going to look at the expression within that quadrant. It makes life a little bit easier because all we're looking for then is we're looking at the quadrant, we're looking at the sign, and we are not reducing because our acute angle is already there. Our acute angle, which is already there, is now just theta. They've already, hypothetically, done the reduction for us by saying 180 plus something, and that something will be our conclusion. Like in the last video, it was like 180 plus 30, and 30 was our reduction. So our reduction in these types of questions will always be whatever your quadrant is, your sign, as well as now just theta, because that is your acute angle. So I'm just going to write here, that is your acute angle, and it is across the whole way. There's your acute angle, here's another acute angle. That's what theta is. Anyway, let's jump straight in. So we are first going to look at the quadrant with which we are in, and it says 180 plus theta, so obviously we are in this quadrant, and it's saying there, it's saying tan. And what do we know about tan in this quadrant? Well, it's positive. And then we have tan and just our acute angle times by 360 minus, which is in the fourth quadrant. What do we know about sine in that quadrant? Well, sine is negative, so I'm going to pop a bracket here. So what happens is, in some cases, when people don't pop the bracket here, somehow this multiplication sort of disappears and it becomes like just a really big minus. And then you've changed the whole order of operations for the sum, which means that you can create a breakdown for yourself, which means that you will get no marks further. Okay, let's look at this last one. 360 minus theta, which is in the same space of the last one. That's tan, so that's a negative tan theta. What people fail to understand here is that these ratios, remember tan is opposite over adjacent, sine is opposite over hypotenuse. That's why it's called a ratio, because it's a fraction. Its end conclusion is a fraction. But anyway, they are just variables. So what we're looking at here, if I said tan theta was x and sine theta was y, and again tan theta was x, this is basically what we are looking at when you see this. They are just variables. That's all they are. And if I had to go and simplify this very easy expression, the x's would cancel and you would just be left with a negative y over a negative 1, and in our case that would just be a y if we were working with x's and y's. But in this case, because we're working with sines and tans, the same thing will happen. The tans will cancel, leaving you with a negative 1 here, which just leaves you with a positive sine theta. And I think that's the most, what's the word I'm looking for? Misconception here is that people don't recognize sine, tan, and cos as a variable in trig. And that's all it is. It's just a trigonometric variable. Okay, let's look at the next one. So you can try it out yourself, see how far you get, and then so you can pause it and do it yourself. But anyway, I'm just going to start. So tan theta plus x, so that's in this quadrant. That is tan's quadrant, so that's a positive tan x times by cos 360 minus, let's take a look here. That is, remember we're working with x here, so don't get confused. The variable that you write in your answer must be x. Cos 360 minus, that is this quadrant, that is where cos is positive, so cos of x, here's a plus. Tan 180 minus, this is over here, tan is negative, remember, bracket when you have two operations next to each other, times by, this is already in its acute angle form because x is classified as the acute angle. Everything over 360 minus, again that is in cos's quadrant, so negative tan of x. Okay, so let's go figure out what is happening over here. So I know when I multiply those two, it's going to become minus. So let me go and rewrite this. So I've got tan times cos of x minus tan of x times sine of x, all over, my beautiful straight line, negative tan of x. Okay, let's go and change this color, and let's write this all as if there were variables. So let's say tan was x, cos was y, there's another x, let's make sine a z, and there's tan, so tan was just x. So what would I do here? I've got a binomial over a monomial, and I mean, for me this is an algebraic fraction, so the only way that I can do any cancelling to simplify is if I get the same sort of expression over each other. For example, bar over bar or mono over mono. The easiest way to go about it is if I've got a monomial over a monomial, and that means I need to focus on what's happening in this numerator, and I'm seeing a common factor. So I'm going to take out that x, and I'm going to be left with y minus z over negative x. And there you will see that those will cancel, leaving you with a negative 1 at the bottom, which changes that to a negative y plus z. Remember, all of this is in your mind's eye. This is what you're imagining when you're looking at these trigonometric variables. But let's go back to the red, and let's do the same thing. So I took out the tan x because that's what I saw as common. And I've got cos x minus sin x all over negative tan x. The tan x is cancelled, would leave me with minus 1 at the bottom here, which is just a negative cos x plus sin x. It's as simple as that. Okay, let's look at the next one. So again, you can pause it, see what you can do yourself, but I'm going to start. So 180 plus, that's tan's quadrant, this is sine, so that's a negative sine theta. 180 minus, that is sine's quadrant, that is sine, so that's just a positive sine. Cos is already in its acute form. That is tan's quadrant, so this is a negative cos theta. And that is cos's quadrant, so that is a negative sine theta. So let's take a look. I could go and put these two together if I wanted to, but I mean, why would I do that? Because if I think about it, this variable can cancel with that variable, leaving me with a negative 1, and this variable can cancel with this variable, leaving me with another negative 1. What I'm looking at is a positive 1, and I times these two together, I'm looking at a positive 1, which does nothing in the denominator. So my answer is just negative sine theta. Well done if you got that correct. And pause it, see what you can do with this one. Okay, let me start. So 180 plus, that is tan's quadrant, this is cos. So that's going to be a negative cos of x times by 180 plus, that is tan's quadrant. So that's a negative tan of x. Uh-oh, what's happening here? Well, do you see with all of these, the number is first, then the acute angle. So what's going to stop me from just swapping these around? Absolutely nothing. And do you see how that is that? Great. So that's going to leave me with a positive sine x. Now, what can I do? Depending on how far you are in trig, it'll come across in my next few videos. What you'll pick up is that there's something special about tan, something very special. So tan is an identity that looks like this. A lot of you might have done it in your class in grade 10. If you didn't, well, now you're seeing it for the first time. So what we can do is we can go and replace tan with that. Taking into consideration that cos is naturally over 1. Do you see that those now will cancel? And then what I'm left with is a negative sine of x over a sine of x. And again, those will cancel, which just leaves me with a negative 1. So this was a little bit of an eye-opener for us without doing, I haven't done identities yet in my videos. But it is something for you to be aware of when you do identities. Yeah, some of you guys have probably already, like I said, done it in grade 10. So it's all good. Okay, thank you for watching, guys. I hope you had I hope you wrote a lot of notes. That's what I'm saying. I hope you paused every single time, and I hope you tried them by yourself. In the next video, we're going to be looking at cofunctions and also the negative angle, which is popping up in quadrant 4, which is also part of our reduction angles. And then we're going to be getting into more challenging questions. This is very beginning questions. Okay. Have a good one. Please share and subscribe and share with all your friends that are struggling. Hopefully I can help them. And if you have any suggestions on any videos that you need me to make for you, just pop it in the comments and I will be more than happy to make those videos for you. Have a good one.